Okay, for topic 3, we're going to look at applications, which by now we know generally means word problems. Okay, so example 3 says, solve each problem, include correct units with each answer. Okay, so for part A, it says you have a you have a coupon for $2 off a purchase of 5 frozen pizzas. So if you buy 5 frozen pizzas, you get $2 off the total. Each pizza is $4. How much will 5 pizzas cost after using the coupon? Okay, so what we want to do is we want to create a model. Remember, we're in the order of operations, so we don't necessarily want to piece this together. We want one single model that'll represent this scenario that we can then use the order of operations to solve. Okay, so I know I need to buy 5 pizzas. Okay. I also know that each of those 5 pizzas is going to cost $4. So I would want to multiply to get my total. But as long as I buy 5 pizzas, I get a $2 off coupon. So that's my model. I'm going to take my 5 times 4, that's going to give me the total cost, then I want to subtract the value of the coupon. Okay. So using the order of operations, we would multiply first, subtract second. So 5 times 4 is 20. So I'm going to replace 5 times 4 with 20 and then rewrite the problem. And then 20 minus 2 is 18. So that's pretty easy to do, nothing scary. We do stuff like this all the time when we go to the grocery store, but what we want you to see is that, hey, behind that just real world day-to-day kind of arithmetic is an order of operations type problem. Okay? Next up, we have part B. It says you went to the concession stand at the baseball game and got 3 hot dogs for $2 each, 3 orders of nachos for $3 each, 3 small drinks for $1 each. If you gave the cashier 4 $5 bills, how much change will you get back from the cashier? So again, remember, we're in the section on order of operations. We want to create one model that we can then use to solve this particular situation. So one model where we use the order of operations to simplify. So let's think first. When we're doing a situation like this, we have money that we give to the cashier. The cashier tells us our total, subtracts it from what we give, and then the cashier gives us our change back. So basically, we have money given to cashier minus total cost of goods. That equals our change. Okay, so let's first figure out how much money we gave the cashier. So we're told that we gave the cashier 4 $5 bills. Well, that's going to be 4 times 5. From that, we want to subtract the grand total of all of our purchase. So like everything we bought, we want to figure out a grand total. So I'm going to do subtraction, and then I'm going to do a set of brackets or parentheses. And in those brackets, I'm going to figure out how much I spent total. Okay, so let's go through this piece by piece. Let's start with the hot dogs. We bought 3 hot dogs, each costing $2. To that, we're going to add the cost of the nachos. So we got 3 orders of nachos for $3 each. To that, we're going to add the cost of the drinks. We bought 3 small drinks for $1 each. Everything that's in these square brackets right here, that indicates how much we spent. Okay, so this is our model. This shows the money that we gave the cashier minus the total cost of our goods, and the result is going to be the change that we get back. So let's work on the order of operations. So first, I want to take care of what's in those brackets, that big set of brackets. So I'm going to say, okay, 4 times 5. And then in the brackets, we have multiplication and we have addition. And we know from the order of operations that we have to do the multiplication first. So we're going to do 3 different sets of multiplication here. So first, I have 3 times 2. That's the cost of the hot dog. So 3 times 2 is 6. I'm then going to do 3 times 3, the cost of the nachos. So 3 times 3 is 9. And then finally, 3 times 1 is 3. That's the cost of the drinks. Okay? And if I add up everything in these square brackets here, that's how much we spent. So we still have 4 times 5. And then inside parentheses, we have 6 plus 9. So 6 plus 9 is 15. 15 plus 3 is 18. And unfortunately, this looks really similar to the previous problem, complete accident. Okay, so let's see here. Now we have, at this point, we have multiplication and subtraction. Let's do our multiplication first. So 4 times 5 is 20. So I ended up giving the cashier a total of $20. My bill came to $18. If I subtract those two, that tells me I got $2 in change. So $2 in change here. And then I did forget to describe this answer. This was the total cost of 5 pizzas with a $2 off coupon. So there you have it. When you have problems like this, you're describing some situation in the real world. You want to create one model that describes that you can then use the order of operations to simplify. Let's look at example 4. So example 4, I'm actually going to shrink my screen a little bit so it fits better. Example 4 just says short answer. So what's happening here in example 4 is we have this table of values. So this table of values shows the average high temperature in Barrow, Alaska. So for each month, what was the highest temperature of that month? Okay, so January, the high was a whopping -7. February was -11. March, -8. April, it finally starts to warm up. It's 7 degrees. May, 25. June, 39. July, 46. August, 43. September, 34. October 20, November 5, December -5. So that's kind of what this information is. That's the highest temperature for each month in Barrow, Alaska. So part A says, what is the sum of all the temperatures or of all the high temperatures in Barrow, Alaska? They just want us to basically add up this list of numbers here. It would be completely appropriate for something like this to use a calculator because we're dealing with 12 values. That's a good bit. But for the sake of just practice, let's go 2 by 2. So I'm going to start adding here. So the first 2 months, we have -7 plus -11. When you add two numbers with the same sign, you just add and keep the sign. So 7 plus 11 is 18. So we get -18 here. Let's look at the next 2 months. So the next 2 months, we have -8 plus 7. So when you're adding two numbers with different signs, you want to find the difference in the positive and negative. So 8 minus 7 is 1, but what did I have more of? Did I have more positive or more negative? In this case, I had more negative, so I get -1. Now here for May and June, it's nice and toasty. So we have 25 plus 39. If you need to do a little side work, that's okay. So off to the side, we have 29 or 25 plus 39. 9 plus 5 is 14. Carry a 1. 3 plus 2 plus 1 is 6. So here we get 64. 2 by 2, let's see, we've got 46 plus 43. Again, if you need to do side work, that's totally okay. You should get 89. 2 by 2, let's see, we have 34 plus 20. 34 plus 20 is 54. And then finally, -5 plus 5, that's just going to be 0, okay? So we've got it down to 6 data items that we need to add up. So let's go 2 by 2 again. Well, -18 plus -1, we're adding two numbers with the same sign. You add and keep the sign, so that's -19. I'm going to do a little bit of side work for 64 plus 89. So 9 and 4 is 13, carry a 1. 8 plus 6 plus 1 is what, 15? So we get 153. And then 54 plus 0 is just 54. So finally, we have -19 plus 153 plus 54. And we just have 3 more to add. So let's see. I'm going to add my 2 positives, then I'll go back and add my negatives. So let's see over here. We've got 153 plus 54. So let's see, 3 plus 4 is 7, 5 plus 5 is 10, carry 1, so we get 207. So -19 plus 207. One more addition or subtraction, and then we're done finally. So let's see, 207 plus -19. We want to find the difference in positive and negative, so it's really a subtraction. I can't take 9 from 7, and I can't borrow from 0, but I can borrow from the 2. So 2 becomes a 1. 0 becomes a 10, and now I can do my borrowing. So I still can't take 9 from 7. Okay, so I would borrow. 10 becomes 9. 7 becomes 17. So 17 minus 9 is 8. 9 minus 1 is 8. And then there's nothing to subtract from the 1, so I just bring it down. So the sum of all of the high temperatures is 188. Okay, now again, for a problem like this, I've discussed this in many videos, when to use a calculator, when not. A problem like this, it would be completely appropriate to use a calculator just because there are so many values, okay? For the sake of practice in this video, we did it piece by piece, but again, a calculator would be fine here. Part B, it says, what is the average high temperature for January and February, okay? So you may not remember this, but when you're finding the average of two numbers, you take value 1, you add value 2, and because we're looking at two values, we then divide by 2. That finds our average. So for value 1, we had -7. For value 2, we had -11. We want to take that and then divide by 2. Now, we already know that -7 plus -11 is -18. And then to find the average, we just divide it by 2. So we would say the average here is -9 degrees Fahrenheit. Okay? And then finally for part C, it says, what is the difference between the highest and lowest temperatures from this table? So if we look at the highest temperature, I think we can say pretty successfully, let me change this to a color that's going to be easier to see. Red, we could say the highest temperature is 46. I can say that the lowest temperature is -11. So we want to know the difference between these two. So let's see, let's go back to the regular one. We could say 46 minus -11, and that would be the difference between these two temperatures. So when we have subtraction like this, again, we frequently convert it to addition. So this is really 46. Instead of subtracting a negative, we want to do the opposite of both. So we want to add a positive. So 46 plus 11 is going to be 57. So there's a 57-degree difference in the highest and lowest values. Okay. So there you have it, one table, 12 values, a lot of math work, okay? So make sure you understand how to do all these. Again, a table like this, it would be completely appropriate to use a calculator if you want to. Just make sure you show us the setup. Show us what you told the calculator to do, all right?